My teacher assigned me the most challenging homework ever, calculating numbers from 0 to infinity. As I delved into the world of numbers and theories, I invite you to join me in this fascinating journey. Hello fellow math enthusiasts, welcome back to our channel. Today we're embarking on an exhilarating exploration of infinite series, the kind that keeps mathematicians up at night. Buckle up because we're about to unravel the mysteries behind endless additions. Ramanujan summation, the Indian trailblazer. Our first stop takes us to the brilliant mind of Indian mathematician Srinivasa Ramanujan. Picture this, a series stretching to infinity, seemingly defying summation. Ramanujan proposed a fascinating formula that bridges the gap between integral limits and countable sequences of numbers. It's like connecting the dots in the cosmic math canvas. Next, we encounter Cesaro summation, a method that throws the rulebook out the window. Ernesto Cesaro, an Italian analyst, dared to assign values to divergent series. Imagine defining the sum as the limit of a sequence of arithmetic means of partial sums. It's like finding the heartbeat of infinity. Hold your hats for Grandy's series. It's an infinite dance of ones and negative ones, swaying between 0 and 1. But Cesaro summation steps in and whispers, guess what? The sum of Grandy's series is a half. And let me explain to you, my friend. Let's consider a series which we'll call S. It's defined as follows: S1 minus 1 plus 1 minus 1 plus 1, etc. Now, if I were to ask you for the value of this series, you'd likely say it depends on where we stop. For instance, if we stop after the first two terms, the answer would be 0. If we consider the first three terms, the answer becomes 1. Continuing this pattern, whenever we stop at an even number of terms like the first two or the first four, the answer is 0. Conversely, if we stop at an odd number of terms, the answer is 1. Now, let's subtract both sides of the equation from 1. So now we have 1 minus S1 minus 1 minus 1 plus 1 minus 1 plus 1 minus etc. Notice that the second side of the equation looks familiar. It's the same series S we defined earlier. 1 minus 1 plus 1 minus 1 plus 1 minus etc. So we have 1 minus S equal S. Solving for S equal half. This result can be puzzling because it involves an infinite alternation between 1 and 0. Some people criticize it while others find it logically intriguing. Regardless, let's remember this result. We'll call it S1 as it might prove useful elsewhere in our journey. Now we need another series to prepare for finding a result related to our first equation: 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus etc. Let's define another series, which we'll call S2. Its form is as follows: S21 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus etc. We can play with this mathematical series as we like, following our own rules. Now let's create another S2 and calculate it with the first one. So we got S2 plus 2 equal 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 1 minus 2 plus 3 minus 4 plus 5 minus 6. Expanding the terms, we get 2S21 minus 2 plus 1 plus minus 4 plus 3 plus 5 minus 4 plus 3. Notice that the right side of this equation resembles the famous Grandy series 2S21 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus etc. We already know the answer for Grandy's series 2S212, therefore S2 equals 1/4. Now let's revisit our first series and call it S3 equal 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus etc. Next, we'll subtract S2 from S3. Simplifying the terms, we get S3 minus S21 minus 1 plus 2 plus 2 plus 3 minus 3 plus 4 plus 4 plus 4 plus etc. This simplifies further to S3 minus S2 equal 4 plus 8 plus 12 plus etc. Now let's factor out 4 and divide by the sum of natural numbers S3 minus S241 plus 2 plus 3 plus 3 plus 4 plus etc. We recognize that the sum inside the parentheses is S3 again, S3 minus S24 S3, solving for S3, given that S2 is 1/4. We find that S3 equals minus 1/12. Divergent series have sparked heated debates among mathematicians. Some argue that assigning values to these series is akin to bending mathematical rules, while others see it as a creative leap. The clash of perspectives keeps the field alive and dynamic. Historical battles throughout history, mathematicians have grappled with these infinite sums. Think of it as a tug-of-war between intuition and rigor. Grandy's series, for instance, oscillates between 0 and 1, challenging our understanding. The The struggle lies in finding a balance between mathematical elegance and practicality. Ramanujan's intuition, Srinivasa Ramanujan, our Indian trailblazer, possessed an otherworldly intuition. His formulas often defied convention, leaving fellow mathematicians both awestruck and skeptical. Imagine the late-night discussions, scribbled notes, and sleepless nights as they wrestled with these ideas. The infamous result of applying Ramanujan's magic to the harmonic series. It's not a straightforward sum, it's a regularization trick. Mathematicians grapple with the tension between mathematical rigor and the allure of unexpected results. Beyond the classroom, these theories aren't neatly packaged for textbooks. Mathematicians venture into uncharted territory, fueled by curiosity. They question, explore, and sometimes stumble. It's a journey of discovery, not just memorizing formulas. So, while we explore these mind-bending concepts, remember that math isn't about having all the answers, it's about the thrill of the chase, the struggle, and the occasional eureka moment. Don't forget to like, subscribe, and hit that notification bell. And as always, keep those pencils sharp and your mind sharper, etc. Stop at an even number of